Hello. What's going on? What's going on? What's up, David? How you doing? I'm in here. Hello. Going. Get started. Go. There. All right. There. It looks like we're live now. Thank goodness. Okay. Cool. Looks like we're good. How's it going? How's it going? How's it going? How's it going? Birthday. Yes. Happy birthday. Happy birthday. Oh my goodness. Welcome. Welcome everybody. Welcome everybody to your last week. Your last week of live streams. Yes, you heard me right. Your last week of live streams. Your last week of live streams. I don't know if that went out yet, but yes, we are to let you know that this is the last week of live streams. Don't know if that's a good thing or not. So hopefully everything's going well. Hope you guys had a good weekend. Um, I miss even Steven. Yes, I mean I can always draw even Stevens, cohort here with his legs here, and he had his big eyes and the little top hat. Didn't he have the top hat? Or no, he didn't have a top hat. Yes, yes. All right, so here's how this is going to go. Those of you who have been following along with me this whole journey these past little month and a half. Great. I appreciate you guys. I really do because it's definitely definitely a different thing going on here. So how this is going to work, I am going to for the next for a little bit of time here, I'm going to go through topic 7 and topic 8 in its entirety. I'm going to move quick. I'm going to move quick to make sure you guys have this down. Have have this as the as your the right way of doing things here. Again, topic 7, topic 8. It's a lot of information, so I'm going to move quick. Feel free to pause this. Feel free to go back and go over what I'm talking about. But I am going to go quick. Okay, so but I'm going to try to leave a few, like I said, leave a few at the end. If I don't get to a question or something in the chat, that's just because I'm trying to move quick on this, okay? But I want to make sure you guys have this, have at least the first two. Depending on how far we get through, we'll do the same thing tomorrow with another two topics and try to get through at least, half of everything here. At least something along those lines. But needless to say, I'm going to try to get myself off the screen here and I'm going to get started here. So I know we started talking about this stuff on another live stream, but here's the, you know, here's the thing. I want to make sure you guys have the right exact answers on this, which is always good. With the point now, it's the last week of live streams, so I want to make sure you at least have this here. So here we go. Parallelograms and rhombi or rhombuses, or I guess that's a new word, rhombi or something. Know that when you're finding area of a parallelogram or a rhombus, tells you pretty much right there. Area is base times height. When you look at number 1, your base of 4, your height of 9. If area equals base times height, area equals 9 times 4, area is going to equal 36. And it's 36 meters squared. Let me take my thing down here. Your area on this is going to be 36 meters squared. Okay. Remember that your base and height are what creates that 90-degree angle when it comes to parallelograms or rhombuses. And yes, I said rhombuses with many, many things here. So that's one. So that's one. We're going to go to number 2 here. Same thing works. 8 times your 7.9 as your height. 8 times 7.9. You can sit here and you can go through and take your 8 times your 7.9 and it's going to give you your 63.2. Your 63 0.2, and remember, it's centimeters squared with that. Area is always squared on this, okay? That's 2. We're going to go to 3. Again, all this is telling you is just it's a rhombus or a parallelogram. It's just doing it in the word format, woohoo, right? So the rhombus has a base of 14 and a height of 9. So again, purely 14 times 9. 14 times 9, and just because I believe it's 126, 14 times 9 will give you 126 inches squared. 126 inches squared will be your for number 3. Okay, I hope I'm getting this across, but again, just want to. This is kind of, it's just kind of not common sense, but it's just kind of a, pretty straightforward. Area, base times height for the parallelogram, base of 12, a height of 8.5. Guys, 12 times 8.5 will give you 102. So your area of number 4 is 102. And again, that's feet squared. So that's 102 feet squared. Okay, 102 feet squared with that. Number 5. Now, number 5 will require a little bit of manipulation with the formula. So if you have area equals base times height, now it tells you here the rhombus has an area of 375, so 375, and a base of 25. So this is just going back into saying evaluating your expression here, evaluating your expression by just filling in what you have. You're filling in what you have right there. So 375 is going to equal 25 times h right there. So then divide both sides by 25. You're trying to find what the height is, right? The 25s will cancel. We'll leave your h on the right. And then proceedingly, 375 divided by 25 will give you 15 millimeters. 15 millimeters should be your height in that instance right there. Okay, that is this section in about 3 minutes. Okay, if anything comes up, put it into the chat. I'll try my best to kind of go along with doing this. Okay, like I said, so if anything comes up as I'm going through this, just put it into the chat, and I'll try to, like I said, I'll try my best to address it. But like, I'm gonna try to just keep moving here. What's happening? All right, number two. So here we go. Find the area of the triangle. Area of the triangle. Area equals 1/2 base times height. So your base of 2, the 90-degree height of 5. If my area is 1/2 the base of 2 times the height of 5, area equals 1/2 times 10. Your area is going to be 1/2 of 10. 1/2 of 10 is going to be 5 yards squared. 5 yards squared will be number 1 for that. Right. Number 2. So number 2, again, 1/2 base times height. 1/2 your base times your height. Base of 8, your height of 6. Don't worry about that 10 right there. 1/2 your base of 8, your height of 6. You can either do it and say, well, what's 1/2 times 8? 1/2 of 8 is 4. 4 times 6 is going to be 24 feet squared. 24 feet squared. 24 feet squared will be for number 2. Number 2 on that. All right, number 3, your base of 12.4, your height of 18. Guys, you can fill these in. You can fill these in just for the sake of time. You should have something along the lines of 111.6 centimeters squared. And then for 4 should be 10.5. Guys, that's simply 10.5, 10.5, 10.5 meters squared. Hopefully you can read my chicken scratch right here. 3 and 4 respectively, right there would be those. Guys, that's simply filling in. That's simply taking your formula of 1/2 base times height and just filling in your variables and just multiplying it out. Okay. That is 2. That is 2. Move forward here. There we go. So we move forward. We Talk about trapezoids and kites right here. Trapezoids, trapezoids and kites. Remember, trapezoid. A trapezoid has a base 1, base 1 plus base 2 all over 2 times your height. So that's how you're going to find your trapezoid. Your trapezoid area is taking base 1. Remember, they're the two that are the parallel. So like in number 1, it's 6, and then it's going to be 5. So you're taking 6 plus your parallel base on the other side, which is 5. 6 plus 5 over 2 times your 90-degree height, which is 11. When you do that and you compute that, just to show you this one. So then when you compute this right here, you take, it's 11. 11 divided by 2 is 5.5 times 11 is going to be 60.5. So it's going to be 60.5. 60.5, and that's centimeters squared. Guys, you can do the same thing for this. Your base 1 is 13. Your base 2 is going to be 1, and that height is going to be your 12. You fill it in. You fill it in. And you compute it right there. Okay, I'm going to move to number 3 here. When we talk about our kite, so when we talk about our kite on this instance, remember that this is purely taking diagonal 1 times diagonal 2 and dividing it by 2. Diagonal are the two dashed lines that you see inside of the kite there, inside of the kite. So in this instance, for number 3, diagonal 1 is going to be 8 plus, let me get the other stuff off the screen. Diagonal 1 should be your 8 plus your 4. So it's going to be 12 times your diagonal 2, which is your 4 plus 4, 8. 12 times 8 divided by 2. 12 times 8 is 96 divided by 2, which will give me 48. That'll be 48 inches squared. So number 3 should be 48 inches squared on that. Okay. If you took so just to kind of, so that you guys have answers here for number 2, number 2 should be 84 meters squared. And then doing what we just did for number 3, for number 4, should give you 28 inches squared. Okay. All right. I believe with number 4, we went through this before. It's simply taking your polygon right here and cutting it into 2 parts that you can actually measure. There's no formula to measure a polygon that looks like this. You have to sit there and go, all right, I gotta separate this into 2. There we go. Into two polygons that we know. So like in this instance, looks like 2 rectangles in this instance. So when you actually sit there and you would find the area of this and you find the area of this. So when you do that, you should come up with along the lines of 33 units squared. It should be 3 times 2, 3 units times 2, which will be 6 units squared. And then your 3 here by your 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 9 is going to be 27 plus your 27 units squared. You add these up, it'll give you your 33 units squared for that one there. Okay. Moving right along. So the next year we'll talk a lot about nets as well too. So I know you guys did this a little bit in intervention and everything of that sort too. So in 1 and 2, you want to classify these solid figures. Okay, it actually tells you on this. If you look to the right, if you look to your left, and it says this figure has 2 congruent parallel bases. 2 congruent parallel bases. Okay, 2 congruent parallel bases. So it is a prism. So that if it has 2 congruent parallel bases, it is a prism. Those two bases are triangles. So triangles. There we go. So your classification for number one on this is a triangular. Wow, triangular prism. That's a triangular prism. Two triangles in a prism. Okay? Triangular prism for one. So then, consequently, looking at number two, you have a base of a triangle, but they come up to a point. They come up to what we call a vertex. They come up to a vertex in this instance. So if they come up to a vertex that is a triangular pyramid. You guys have seen pyramids before in some, in some facet right there. So the triangular pyramid for number two. Okay, triangular pyramid. Look at number three. Now we talk about a net. A net. If I took this figure, right here, and I look at it like it's saying, you have your base of a triangle, and what it looks like to me is it has almost looks as if you have one face that's a triangle, two faces that's a triangle, and the three faces behind that's a triangle. I pretended like there was like a pin up here to the top at the vertex, and I just pulled that pin. The net should look something like this. And again, if we were in class, I feel like I'm like a broken record sometimes, but if we were in class, we would actually, physically do this. But the pyramid or the net should look something like this. I took these three are the faces, and brought them up to a point. It should look like like that figure. Something like this should be how that net should look right there. Okay. A lot of information, I know, but just want to be able to get you guys a good solid base on this. So in 4 and 5, identify each solid. So each solid from the net. So in this instance right here, if you pretended like these faces that these triangular faces that you had all came to a point in the middle, it's going to come to a pyramid. It's a come to a pyramid point. Again, if we were in class, we'd actually be doing this. We'd actually have little construction time of actually trying to create these things, which is, fun stuff. So it's a square. It's a square pyramid. It is a base of a square coming up to a point. A base of a square coming up to a point. So that is a square pyramid for number four. Number four, that's a square pyramid. Okay. Number five, I would hope that looks kind of familiar to number one up here. You think about this, you look at this right here, and look down at this net. If you brought both faces, you brought both triangles here up and brought your other sides up, it would create a prism. It would create a prism in that instance. Okay. Okay. Let's move down on this. What it's looking like time-wise is I'm going to get through 7, and then I'll get through 8 tomorrow, 8, and then any other extra questions you guys might have. So that's what it's going to look like here to make sure you guys have this. So surface area, ladies and gentlemen. So surface area on this. In my instance, the idea is that you're going to look at both faces. So what you have right here, you have a rectangular prism. You have a rectangular prism. So you have three different sets of sides. So if I have this front side, it has a length of 6 and a height of 5. So 6 times 5 is 30. I know that I have two sides to that. So 2 times 30 will give me my surface area for two sides of that. Adding 30, 2 times 30 plus then on your side, your 3 times 5, what's on this side will also be the same on the other. 3 times 5 will be 15, so 2 times 15. And then finally, on that top side, it is a length of 6, but a width of 3, because your 3 right here will be what's up here. So 6 times 3 is 18. So it's 18, 2 times 18. So with that being said, 30 times 2 is going to be 60. 15 times 2 is 30. 18 times 2 is 36. When you add all of this together, when you add all of that together, it looks like it is 126 feet squared. So when you add everything of that together, it should give you 126 feet squared. Guys, when you do number 2, the best thing to do is how I just did it. You break it down as each side. So you know that you have this side as well as the back side. And then you have 1, and then 2, and then 3 on the left there. Okay. Again, a lot of stuff. I am well aware of that. So 3, cube. Well, what's a cube? Cube. Each face is the same. It's all square sides for the cube. That's why you only have one length of 9.4. How many sides are on a cube? There are 6 sides on a cube. So take your area for one of the faces. So for one of your faces on this, it's 9.4 times 9.4. It's going to give you this 88.36 times 6 sides. So times your 6 sides will give me 530.16. 530, 530.16. Okay. Almost there. Almost there. A couple more here. So 530.16. All right. Again, what this is doing for the rectangular prism, personally, I would draw one if I were you. And if I was doing this and I said, well, the length is 12, the width is 7, and the height is 3, and then you would do what we did up here. And you would sit there and say, okay, I have the front side and the back side, and then the left and the right, top and bottom. Like everybody has their way of doing things. I mean, for me, I like seeing each side written out. That's just me. Everybody's different. So, but to give you some differences here. Number 2. So if you were to put everything out, number 2 should be 440 centimeters squared. For the cube for number 4, so for the cube for number 4, if the side length is 7, 7 times 7 is going to be 49, and there are 6 sides to a cube, right? 49 times 6. So if I took 49 times 6, 49 times 6 is going to be 294. So it's going to be 294 centimeters squared. Okay. There. Time is ticking. Time is ticking. 5 and 6. If you were to draw these out, I'm trying to look at my written down information here too, but it should be 282 and then 214 centimeters. Again, these would be your drawing them out and do this. We could do the net, but in this specific time, if anybody wants to actually know about drawing a net, please let me know. I mean, we'll talk about that when you see me hopefully next year there. So we'll talk about nets. We'll do all that good stuff. Okay, let's get down here. Almost there, guys. Almost there. So 7 surface area of pyramids. Surface area of pyramids here. It's just like how we did. It's just like how we did up top with all that stuff. It's just you're finding your surface area for each face. So a triangle has the surface area of 1/2 base times height. So a base of 4. And what this 5 should be pointing to, 5 should be pointing to the height of that face right there. Don't know why it was doing it that way, but if I have my 1/2 base times height, a base of 4, a height of 5, 1/2 of 20 should give me 10. So each face, so there's 4 faces to this. 4 faces at 10 each should give me 40. And then the bottom is 4 times 4 plus your 16 should give me 56 inches squared. 56 inches squared. I know I'm throwing a lot here, but 56 inches squared. And again, 2 should work the same way to where you're just finding your base. Remember what creates that 90 degrees, your base of 7, your height of 6.1, and then you're doing that for your 1, 2, and 3 sides right there. And then on the bottom, actually 4 sides, but and you're doing that for the bottom as well too. So when you do that, you should have something along the lines of 85.4 centimeters squared. 85.4 centimeters squared. Number three, each side of the base of a square pyramid is 10 feet, and the height of each triangular face is 7 feet. Just drawing your square base. So it has 4 sides. This is where a net would be the best way of drawing it. You would have your net drawn out. And if you went through everything, you find out that your answer would be 240. If you have any questions with any specific parts of this, please shoot me an email. I'll be happy to go further in depth with you on this. Okay, I just want to give a real top end view. So finding volume with fractional edge length. Look at this part right here. And here's the thing. So say for instance, I had this and I said, I looked and I said, well, I want to go 8 times that 4 1/2 times 3 1/2. Length of 8, width of 4 1/2, height of 3 1/2. Okay. If I took an 8 and I multiplied it by 4 1/2, if I changed 4 1/2 to a mixed or to an improper fraction, 4 times 2 is 8, plus my 1 is going to give me 9/2. So 8 times 9/2 times my height of 3 1/2. 3 times 2 is 6, plus 1 is 7, 7/2. So then here we go. 8 times 9 times 7. Move my thing out of the way here. I think this will be enough to go through. So if I took my 8 times 9 times 7, is going to be my 504. So if I have 504 up top, and on the bottom is 1 times 2 times 2 is going to give me 4. 504 divided by 4 is going to give me 126. So your volume for number 2 should be 126 feet. And because it's volume, it is going to be cubed with a little 3 up top right there. Okay. Change these to improper fractions. Well, 2 right there. Change them to improper fractions and then multiply across like I did here. Okay. I mean, I'll admit I tried looking at this 1, 2, and 3, and I was like, "What the heck?" I mean, so if this right here makes it way too crazy in my opinion. But ladies and gentlemen, that's topic 7. I will. It looks like what I'll do then is tomorrow I will talk topic 8. I hope. If you have any questions with any part of that topic on topic 7, please shoot me an email. I'll go more in depth with you on this. But I wanted to give kind of like a top end view of this. Just remember one on this: if you should have something along the lines of 782. That's a good one. 782 and 2/9 inches. I'll admit that's a really crazy one right there. 782 and 2/9. And then if you were to take length times width times height on this, length times width times height, and I'll finish this one up and then I'll let you guys go. If I take 14.3 times 3.8, 3.8 times 4.1, it should give me 222.794. That's That actually is pretty simple right there. 294, and that's centimeters cubed. Again, guys, that's topic 7. We'll talk topic 8 tomorrow. Guys, I hope you have a good day. Please, if you have any questions, I know that's a lot of information I went through right there, but if you have any questions, please reach out. Classroom, email, all that kind of good stuff. But with that being said, I hope you have a good day. I'll talk to you guys soon. Have a good day, guys. See you.